Okay, tonight's homework was using moles with formulas. Trying something a little different here with the the camera. So it says the first question says calculate the percent composition of carbon in C4H10. Okay, and I've got my handy dandy periodic table over here, and I noticed that C has a molar mass of 12, and H has a molar mass of 1 gram per mole. Okay, and I can use that information right in this problem. So I'm going to say that, first of all, there's 4 C's, and each one has a molar mass of 12, so that's a total of 48. And the hydrogens are a molar mass of 10 grams per mole. So the percent of carbon will be 48 out of 58 is equal to X out of 100. And I can go ahead and solve that. Okay, and then you just cross multiply to solve that one. Let's take a look at the second problem here. It says calculate the percent composition of sodium in Na2S. And again, if I consult my handy dandy periodic table, I'll take a note that sodium has a molar mass of about 23 and sulfur has a mass of about 32. I just need to take that into consideration when I do this problem. Make this a little smaller. Okay, so I know that sodium has a molar mass of 23, but there are 2 of them, so that's going to be 46. And sulfur is 32, and 46 and 32 is 78. So that's going to be 46 out of 78 is equal to X out of 100. Cross multiply, solve your problem. Okay, the next part of this has you solve for the percent composition and formula of some of these compounds. So the percent of H is going to be, let's just make this a little bigger. Percent of H is going to be 12 out of 6 times 12 is 72. And 12 here is 84. So 12 out of 84 for that. And this value here is going to be 72 out of 84. This one is going to be 36 out of 42. And this will be 36 out of 42. And again, we just solve it by setting up equal to X out of 100 because the percentage is a number out of 100. 6 times 12 is 6 out of, again, this is 72 and 6, which is 78. So 6 out of 78, 72 out of 78. And then this last one, if I can get at it, is going to be 48 out of 52. And this one will be 4 out of 52. Okay, let's go ahead and take a look. So what is true about the percent composition of 2 different compounds that each have the same ratio of hydrogen to carbon atoms? And that should be that they are the same percentage, is what you should have gotten. Can you determine the molecule's molecular formula based solely on percent composition? And you should say no. Because the percent composition just tells us the ratio. So this could have just as easily been C1H1, C2H2, C200, H200. We have no idea. The only way that we would know is if we knew the actual molar mass of that compound. And number 6 says, is it possible to complete the following table using only information in table 1 without the aid of a calculator or a periodic table? And I think you're probably okay with that. So this is just going to be, again, we know that C, at this point, you probably memorized that C is 12 and H is 1. Now, you don't have to memorize that. And again, if you forgot, you could always look it up on your periodic table. But in this one, it's asking you to do that. I think you guys can do that pretty easily just by taking a look at what the percentages are up here, whatever you got for those percentages. Okay? Okay, and I skipped right over page 3 because page 3 just had all the information to solve this problem. So these are the critical thinking questions here. Find the empirical formula for a compound that contains 82.4% nitrogen and 17.6% hydrogen. Well, if I think about this as a 100-gram sample, then that means that 82.4 grams out of every 100 grams is nitrogen. And then 17.6 out of every 100 grams are going to be hydrogen. So this is going to be NXHY, and this is helium. And then from there, I can just go ahead and convert. I'm just going to erase this here. I'm just going to go ahead and convert those then. I'm just going to convert them to moles, because remember, moles really means particles. So that means that I've got 82.4 grams of N, and I'm going to go ahead and convert those grams N to moles of N. So there's 1 for 14. Okay, and if I go ahead and I divide those out, I should end up with 5.89 moles of N. And then it's 17.6 grams of H. I'll do this in a different color. I'm going to go ahead and convert that to moles of H, which is actually, oops, moles of H should be on top. Sorry, guys. I get for rushing. So I'm going to get rid of grams of H by putting those to the bottom. And I'm going to convert it to moles of H by converting that to the top. And this is a 1-to-1 ratio. So that's going to just be 17.6 moles of H. And if I go ahead and take 17.6 and divide it by 5.89, I should end up with a 1-to-3 ratio. So this is, for every one of these, there are 3 of these. So the empirical formula is NH3. Okay? All right, go ahead and clear that out. Go ahead and just take a look at number 8 then. It says, find the empirical formula for a compound that contains 40% carbon, 6.7% hydrogen, and 53.3% oxygen. So again, if I assume a 100-gram sample, then I can say 40 out of 100 are carbon. So I can do that as 40 grams of C. And I'm going to convert that out to moles of C. So grams of C go to the bottom. There are 12 for every one. And 40 divided by 12 is 3.33 moles of C. And then I've got, let's do this in a different color, 6.7 grams of H. And I'm going to go ahead and convert that out to moles of H, which is a 1-to-1 ratio. That should be pretty easy. 6.7 moles of H. And then the last one is 53.3 grams of oxygen. And I'm going to go ahead and convert that to moles so that I have a particle ratio. Grams oxygen are going to the bottom. This is 16-to-1. Now you can use a forever statement to solve these two. I'm just doing it in the more traditional. This is going to be 3.33 moles of O. So if I look, I can kind of convert these out basically in my head. It's not a big problem. We can change. Let's make a new fancy color. We're going to do this as a 1-to-2-to-1 ratio. So my formula would be C1H2O1 or CH2O. Okay, I hope that helps. I'll see you guys tomorrow. Bye.